the situation here is that we have an object. It doesn't specify where the object is, but where is the object probably? Is it on the moon? Is it floating in water? Where is this object probably? It's probably on a horizontal surface, the class echoes back. So yeah, this is on a horizontal surface most likely. And it's being pulled with a force that's at an angle. So obviously the first thing we want to do is draw a force diagram on this. This force diagram is the most challenging that you'll see. And I'll explain each force. First, there is a weight. The weight is down. The weight is always down. There's a frictional force to the left. Did the problem say to the left? No, it did not. But you can infer that it's to the left because it's opposite the motion. There's a normal force upward. The first thing you notice is that the normal force I've drawn is not equal to the weight. So as you're drawing that, do not make it equal to the weight. But what you're probably observing is if you look at these two vertical forces here, you look at this vertical force and this the other vertical force, these two do have a relationship with this one. And if you think about it, you probably know what that relationship is. That relationship is that these two add up to this force weight. That's not absolutely crucial in doing this problem because I gave you the frictional force. I just said it's 5 newtons. But for a bonus type of question, if I ever asked you to calculate the frictional force from the coefficient of friction and I didn't give it to you, you would need the normal force, so you would need to know this. Now, this came up on the on a recent angled problem we did. I want to point out that the reason I've drawn these components in, those are very, very important to understand those components. What you really want to do is once you've drawn those components, you can kind of ignore that force. Once you've drawn those components, you can ignore this force that they came from. Should it still be in the diagram? Yes. But I'm saying we kind of replace them with other forces that are more useful. So we have an angle. We have an angle and we have a hypotenuse. This is 30 degrees. It's very small, but you can tell I just wrote the angle in there. This force is 58 newtons. So look, to get the Ft sub x, I just do 58 times the cosine of 30, using the sine and cosine rules. That is probably the hardest part of this problem, is knowing how to get the horizontal component and knowing that you should get the horizontal component. Because if you think about it, is it the full 58 newtons that is accelerating this thing? No, it's not the full 58 newtons that's accelerating this. It's only the horizontal component that's accelerating it. So this is a big part of what I'm trying to teach you right now, is this. It's only this force that pulls it to the right. And then, of course, friction's a factor. It impedes that. But that's the only force pulling it to the right. So you get a tension in the x direction of 50.2 newtons. Then I write down sigma F equals ma, and I threw in some subscripts there. I threw in these x subscripts just to emphasize it's the horizontal that we're interested in. Now look what I did here. I just put ftx minus f sub f All I'm saying is, it's very simple. All I'm saying is, it's this force minus this force. You can see that in the diagram. And notice that this always comes from the diagram. This comes from the diagram. Next step, I'm just going to put some numbers in. 50.2 minus 5 equals 25A. And then I solve for A. I'm going to pause it for questions. So a couple of questions that were just asked. One was, why is the frictional force to the left and not below the horizontal to the left? In other words, why isn't it opposite that 58 Newton force? And the answer is that friction is not so much opposite whatever force it's competing with. It's opposite the direction it's moving, and it's absolutely parallel to the surface. It's always parallel to the surface. The other question was, what's up? Basically, it was, what's up with the FTX? I don't really get that. And I explained that FTX is just the horizontal piece of that tension, because that's really the key force in this whole diagram. If I had to say that there was one key force in this whole diagram, what's really new about this problem that I'm solving is that Ft sub x.